QR bisects PQS. So the first thing you would do here is you would add arcs to your picture, because that's the symbol we use for angles to show that two angles are congruent. Arcs. Okay, PQR is 2x squared, and RQS is 7x plus 15. I know why you asked about this one. It's because it's a quadratic, isn't it? You didn't need help with the angle stuff. You needed help with the algebra stuff. Okay, so let's set up an equation. We are not going to add them together. That's the biggest mistake students make. They put a plus sign between those two expressions, and really you have nothing to equal it to when you do that. They're equal, they're identical twins, they're congruent angles. So we set them equal. Then you bring everything to one side, because that's what we always do when we factor. You get your parentheses ready, 2x and x, because honestly that's our only choice when we have a quadratic with a leading coefficient, 2x and x. Okay, so we need things that multiply to get 15, so we go to the side. 5 and 3, 15 and 1. Now we get to double one of those. We get to double, and we need to make a 7 out of it. So let's play around with that. Okay, if I double 5, I get 10. Could I make a 7 out of a 10 and a 3? Ding, ding, ding. So the 5 is the one that gets doubled, and this is the pair that wins. If the 5 is the one that gets doubled, I need to put it in a spot where it's going to get multiplied by the 2 when we FOIL. So the 5 is going to go there, the 3 is going to go here. 5 and 3, those are our factors. Now we figure out the signs. We want it to be a negative 7. So we need the 10, whatever's going to turn into the 10, to be negative. So this needs to be negative because it's going to turn into 10, and this one can be positive. Then we set these equal to 0. X minus 5 equals 0. 2x plus 3 equals 0. That's always the last step when you factor. So x is, let's see, add 5 to both sides, 5, and subtract 3 and divide by 2. If you want to put negative 1.5, there's nothing wrong with that. I usually leave it in fraction form. It didn't say to find x. It said to find the measure of PQS. So you have to plug it in. What I would do is just plug it into one of them. You can pick either one. I would plug it into one of them, and I would just double it. Okay? So we would do 7 times 5 plus 15, and then I would double it times 2. 100. And then I would do 7 times negative 3 halves plus 15, and I would double it. There's a big difference there. So it's either an 100-degree angle or it's a 9-degree angle. Next up is number 9. This one is kind of an odd one, but I have a feeling you'll see that again. I can't remember. True or false? Any figure made up of 2 rays is an angle. And you could really interpret this different ways. This is just saying, can you make a figure with 2 rays and it not be an angle? So, I mean, technically I could have a figure. Here's ray A, B, and then here's ray, I don't know, C, D. And that's my figure, and I've got 2 rays, but I don't have any angles at all. So that one's kind of silly, but you're just trying to, anytime you can think of a way to make it false, then that makes the whole statement false. Okay, so number 12. A point in the plane that is not in the interior of the angle must be in the exterior. So let's talk about point B in my picture. Is point B inside my angle? No. Is point B outside my angle? No. It is on my angle. So this is saying if it's not inside, then it's outside. But we're saying no, it could be inside, it could be outside, or it could be on the angle. So it's false. They're both false. This is angle, addition, and bisector part 2. This is number 3. The bisector of an angle is sometimes in the exterior of an angle. So if I have an angle, if I'm going to bisect that angle, if I'm going to divide that angle into two congruent angles, then I can't do that by adding a ray out here. That's not going to divide ABC into two congruent angles. So this is false, because if I'm going to bisect, if I'm going to cut this angle in half into two congruent angles, it's going to have to fall inside, interior of the angle. Number 9 is a good one. Okay, let's first mark this information up here. APC is a right angle, so I'm going to put a nice large right angle marking. BPD is congruent to DPE. So I'm going to put an arc and an arc. So PD is an angle bisector. Okay, so on number 9 it says more information to add on to that. Angle 2 is equal to angle 3. The measures are equal. So instead of adding even more arcs to my picture and kind of confusing all of my arcs, instead of doing that, what I'm going to do is I'm going to call angle 2 X. I'm allowed to do that. I can call an angle X if I want to. If I call angle 2X, then what would I call angle 3? Well, they're congruent. They're equal. Very good, Aaliyah. It's also X. Okay, what could I name angle 4 then? If angle 4 is congruent to angle 2 and 3 put together, good. I could name angle 4 2X. Okay, now, we know that this angle is a 90-degree angle. Do you know what angle CPE is equal to? Well, if APC is 90, then the one right next to it, 180 minus 90 is 90. It also has to be 90. So this angle is 90 as well. So I can kind of do a segment addition statement. X plus 2X equals 90. Because this angle right here is a right angle. It's a 90-degree angle. So I'm kind of doing part plus part equals whole. So from there, you can totally do it. 3X equals 90. X is 30. Find the measure of angle 2. Oh, we're already done because I named angle 2 X. And so angle 2 and angle 3 are both 30, and angle 4 is 60. All right.